A Sky Swinger ride at a theme park is shown in the diagram below, is rotating at 1.2 radians per second. If the arms are 4 meters long and the chains are 3 meters long, find the angle that the chains make with the vertical. So here we have the central pole. We've got a sort of a ride like this, and we have an arm here which is 4 meters long and the chain which is 3 meters long here. So what we're saying is that this distance here is 4 and this chain here will be 3 meters long. Here we have the person riding. So therefore the radius of the circular motion will be all of this distance here. Find the angle that the chain makes with the vertical, which is going to be this angle here. We've got to find the value of that angle here. Okay, we have an acceleration of r times the angular speed squared acting inwards, and we have the weight of the particle, which is mg. So we are required to find angle alpha, this angle here. First of all, we're going to come up with an expression for the radius. Now the radius is going to be 4 meters plus this little distance here. So this distance here is going to be 3 sine alpha. So the radius of the horizontal circle is going to be the 4, this distance here, plus 3 sine alpha. And alpha we have to actually determine. Resolving vertically, then we have mg acting downwards and we have the tension acting upwards. The vertical component of the tension is going to be T cos alpha, and then take away mg, that's going to be equal to 0. Resolving horizontally using Newton's second law, which is F is equal to ma. So we're going to have the tension component here, which is going to be 3 sine alpha is going to be equal to ma. However, we know that a is going to be r omega squared. Right, we know that r is equal to 4 plus 3 sine alpha, so we have t sine alpha. From here we have t sine alpha is equal to m 4 plus 3 sine alpha times 1.2 squared, which from 1 we have that t cos alpha minus mg was equal to 0. If we rearrange, make t the subject, so it's taking mg over here and then dividing by cos alpha, we have t is equal to mg cos alpha. So we now substitute this in here instead of t. So substituting into equation 2, so we're going to have mg over cos alpha times sine alpha from here is equal to 1.44, 1.2 squared times m times 4 plus 3 sine alpha. Now the m's will cancel out, so what we need to realize that the answer will not depend on the mass of the rider of the chair, and even if there's no rider, it all would be the same mechanics. So m has no effect on this problem whatsoever because the m's cancel out. Right, if we rearrange this, obviously sine alpha over cos alpha is equal to tan alpha, so we have g tan alpha is equal to 1.44 times 4 plus 3 sine alpha. Unfortunately, we can't solve this directly, so we're going to use our GDC. So we're going to use our GDC to solve this, or some graphing software or some numerical method. So if we go to our GDC and go to graphing mode, and then we put in 1.44 times brackets 4 plus 3 sine of x, and we'll get one graph here. Notice we're actually in radian mode here, please. We'll get one graph here, and then if we add in the other graph by doing Command G, and we're going to have put 9.8 times tan of x. Okay, we need to do the view window. The only bit that we're really interested in is the pointing section up here, so I'm going to change the view window a little bit. So go to Windows Zoom, Window Settings, I'm going to set x minimum at -1, set the maximum to 5. These are all in radians. And then I'm going to set this one to -2 and this one to 12. Okay, I'm interested in this point of intersection here because that's the solution of the two equations. So menu, number 6, analyze the graph, intersection, to the left, to the right, and we get an answer of, sorry, just move that off the graph, 0.7209. Normally you should try to sketch. So there's the first graph, there's the second graph. We were interested in that point of intersection, so that should be marked clearly, and we've got the answer here, 0.7209. So alpha is equal to 0.7209 radians. If we want it in degrees, then we need to multiply by 180 over pi, convert it into degrees, which will give me an answer of 41.3 degrees. Okay, remind you that it does not really depend on the rider or the chair.